Hello everybody, I'm back with the second video for chapter 2.1 on weathering and erosion. Last time we talked about mechanical weathering. This time in section 2.1.2 we're going to talk about chemical weathering. So our objectives are going to be to identify and explain several agents of chemical weathering, contrast the types of chemical weathering that involve water, and apply concepts of chemical weathering to technological designs. Now, the difference between chemical weathering and mechanical weathering is that chemical weathering is the breaking down of rocks by chemical processes. So, with mechanical weathering, if you have a certain type of rock, say you have limestone, when you're done with the weathering process, you still have limestone. With chemical weathering, if you have limestone and you say put acid on it, you now have new substances. So that is the difference, whether you still have the same substances for mechanical weathering or where you have new substances with chemical weathering. So some of the processes involved in this. The first is hydrolysis. This is the breaking down of a substance by chemical reaction with water. And a lot of times it produces pitting. And so you'll see this pitting here on the underside of that rock. That is probably due to hydrolysis, to chemical weathering, as opposed to just the water of the waves beating on the rock, where down below, this could be chemical, but it's probably a combination of chemical and mechanical because it is further under where that water level is, undercutting that rock. There's also the process of hydration, which also involves water. And this is when minerals change when they absorb water. It doesn't tend to change the mineral drastically, but it can change the crystal structure. What happens is that the mineral will absorb water and apply it into its crystal structure, and that is what happens when you have anhydrite, which is a mineral. It will absorb water and become gypsum. There's also a process called carbonation. This is the process in which carbon dioxide from the atmosphere or soil dissolves in water to form carbonic acid. And this tends to weather limestone and marble. So you see in the background, I have a headstone that looks to me like it's probably marble. And there's some pitting in it and different things that could be due to some mechanical processes, but are probably also due to chemical processes. And one thing that we also need to know is that some of the same factors that apply to mechanical weathering also apply to chemical weathering. As far as climate, wetter climates, because there's more water, there tends to be more chemical weathering. Also, surface area has a huge effect as far as the more surface area that's exposed to, say, the acid produced, the carbonic acid, the more weathering you're going to have taking place. Also, the type of rock. What is its composition? Are the minerals that are in it, do they react with acids readily or with water? So those factors still apply. With carbonation, this is a natural process. This is why soda pop tastes a little bit sour, a little bit acidic, has that tang to it because we put carbon dioxide in it. We carbonate it. That's why this process is called carbonation. And it produces kind of that sour, tangy taste to soda pop. So it's the same idea, and this happens naturally in the atmosphere. Also, acid rain. This is when gases in the air dissolve in water to form acid solutions that weather rock. So there are gases that we release in pollution, especially nitrogen compounds and sulfur compounds that react with the water to produce nitric and sulfuric acid, which then, like the carbonic acid, fall out of the sky and can further weather our rocks chemically, okay, in these headstones, and there has been an increase in that lately. There's also the process of oxidation, a chemical change in which a substance combines with oxygen. The most common is rust. This is commonly why soil in some areas looks reddish, or the rocks on the side of the road look kind of reddish, is because they have a high iron content and they have rusted. And that's why I have this bridge here, this rusty bridge. Okay, so ways to prevent oxidation are you can paint things. That's why there are painting crews that are always going around painting bridges. You can put special coatings on them. You can put like grease or oil on them to prevent oxidation. And you can also coat them with other metals, such as nails are coated with zinc to prevent them from rusting. And finally, there are biological processes that can cause chemical weathering. Plants actually secrete chemicals that weaken rock. In particular, they produce acids. So especially I have lichen and moss in the background here. Soil that contains moss tends to be very acidic because of this, because they produce the acids, and so those acids will break the rock down. And this is linking this to biology. This is important with succession. The first things to grow in an area are our lichens and our mosses, because they will break down the rocks into soil that other plants can then grow in. So it's a very important process. It's very natural. So our objectives were to identify and explain several agents of chemical weathering, contrast the types of chemical weathering that involve water, and apply concepts of chemical weathering to technological designs. So don't forget your 5 questions.